let's start working on closing off the bottom of the cactus. So we're going to come out here to our one segment node, and we're going to drill down inside of this adjustments node, and then inside the cap adjustments node. And we're going to give this node one new input, which is the segment ID, because the closing off of the bottom of the cactus, the amount of shrinkage that we're going to add is going to depend on the ID. So the first ID, as in the bottom segment in the cactus, will shrink the most, and we'll have that shrinkage go from, fully collapsed all the way to normal over a distance of cap segs, which we set to 5 before. The same as we do for the top of the cactus. And now we want 2 new outputs, both floating point numbers. And these are going to be sort of additional shrink factors that will only apply to closing off the bottom of the cactus. We'll call them start bottom shrink and end bottom shrink, and they affect the start and the end of the segment respectively. Alright, let's bring ID and cap segments down to this lower area so we can start using them. Let's copy these 2 nodes, bring them down here, and we will plug the ID into the value input for the map range node. And the from min value will be our cap segments value. And then we'll set the other values to 0, 0, and 1. I'm going to change the contour of the bottom of the cactus by adding a point here and setting it to 0.25 and 0.94. Just from having tinkered around with this myself, I like the overall look. So let's copy these again, and we're going to plug the same inputs into the same sockets on the second map range node. Except that in this second case, we want this to reference the end of the segment rather than the start. So we're going to need a math node with the add function. We're going to add 1. And let's rename it to +1. And drop it here. And then these 2 outputs feed into our final outputs. Now that we're finished the wiring inside this node, let's get out and do the wiring on the outside of it. So here in the adjustments node, let's add 3 new outputs. They're all floating point values. The first one is the secondary adjusted length. Next is the secondary start radius. And then the secondary end radius. These are going to be values that will be used when constructing the segment, but which won't be passed on to the next segment. They'll just be recomputed anew in the next segment, which is why I'm going to call these secondary. Also, I'm just going to make this node a little bigger so I can read these long names. All right, the secondary adjusted length is our adjusted length times our start bottom shrink. So here's our adjusted length, here's our start bottom shrink, and we just want to multiply them. Now what that's going to do is imagine the very first segment in our cactus. The bottom of that segment should be fully collapsed, which means it should have a start bottom shrink value of 0. And giving that segment a length of 0 will actually make it completely flat, which I'm not a fan of. And so rather than using start bottom shrink on its own, what I'm going to do is I'm going to average start bottom shrink and end bottom shrink, so that at least it'll have a little bit of length. So let's just add those two numbers together and then divide by 2. And let's use that instead. And that is our secondary adjusted length. Next up is our secondary start radius, which is our start radius times our start bottom shrink. So again, multiply start bottom shrink right here, and start radius is here. Lastly, we have our secondary end radius, which is going to be our end radius times our end bottom shrink. So again, another multiplication node. Here's our end radius, and here's our end bottom shrink. And then we clean up. All right, let's go one level further out to here, and let's just tidy this up. That's very, very easy. And let me make the node a little bit wider, again, just because some of these names are a little long. And here's what we need to do with these 3 values. We need to bring length and bring it up close to the actual length value here that we're using. And here's what I mean by bringing it close. Here, I'm putting this reroute node right close to the line for our adjusted length. And we'll see why in a moment. And I'm labeling this S for secondary, and also for short instead of secondary adjusted length. Next, we have our secondary start radius, and we want to bring that so that it's right up close to our start radius. And this is our start radius here. I'm just going to label it just for clarity, and then bring this close to it. And then our secondary end radius needs to come and join up with our end radius, which is just this value here. Great. Now what we want to do is, wherever we've brought our little S values up close to the lines that correspond to the original versions of those values, we just want to follow along with those lines. And anywhere where the value is actually getting used to construct our segment, we want to use the new value instead. But where the value ends up getting plumbed all the way through to the output, we'll stick with the original. That is the whole idea, and it goes like this. That's it for length. It was being used up here as the input to the scale node. So now we have our new secondary value. And down here, where length forked and went downward, that fed into the computation that led to the next segment's length. And for that, we'd stick with the original version of length. And now we just do the same with secondary start radius following start radius and secondary end radius following end radius. That should be all the wiring we need. Let's take a look and see how it looks. Okay. Well, when you make a mistake with geometry nodes, the results can be very entertaining. So every single segment here has its start radius collapsed to 0, as if every segment were the bottom segment of the cactus, as if every segment thought its ID was 0. So this is a node that needs an ID and is missing an ID. So if we go into the adjustments node, here it is. We did not give cap adjustments the ID that it required. So let's just create a new input like this. Come back out of here and let's bring ID down and feed it into this node. And let's check again. Much better. So now we've got the bottom and the top of the cactus closing off to a point. Notice that because the radius values that we were using to construct the segment were also the values that were being used to compute the scale of the buds are also smaller toward the bottom in the same way that they get smaller at the top.